Okay, so we tested what the effects of cold exposure were on hornworms. Hornworms are a common pest found in North and Central America. They go about through 5 instars lasting about a month. They're pretty easy to handle in experiments. Here they are in the instars. It's at the early stage, the middle stage, and then at the chrysalis stage. So everyone's kind of talking about cold exposure and how it's supposed to be beneficial for humans, so we wanted to test what those effects are on hornworms. Some of the effects on humans is that they go through like increased circulation, experience reduced stress, and an increase in metabolism. Our hypothesis was that rapid cold exposure would try to stimulate varying effects on the hornworms.
So the fridge we used was set at 1 degree Celsius, and we used aluminum pans to put the worms in the fridge, and we chilled those overnight. And we used aluminum pans because aluminum's good at a good conductor, so they could chill easy. And then having that actual touch with the worms was important for actually simulating a cold plunge, because if we were just to put them in the fridge with just airflow, they wouldn't get nearly as cold. So we had 3 groups, a 2-minute group, 5-minute group, 10-minute group, for how long they were in the fridge. We recorded their weight and the number of hornworms in each group every 2 to 3 days. We fed them a protein carbohydrate mix every other day, and they were kept under a light at room temp. And for analyzing our data, we used a t-test to determine the significant difference between our data sets, and then we used that to find the error between the averages for each trial.
For our results, all the hornworm groups rapidly exposed to cold experienced less weight gain than the control group. The 5-minute group in trial 1 experienced the biggest size increase out of the treatment groups, but in trial 2 it was by far the worst. And this could be due to just it being a weird outlier, or in trial 2 a lot of our worms died off, and so that could also play a big effect. We didn't have that much data to go off of. All groups in trial 1 peaked on day 7 of the trial, besides the 10-minute group, which kept on going. We ended the experiment on day 8, so we never actually saw where it truly peaked. But that just shows how cold exposure kind of delays growth in hornworms. And then to determine significance, we used a t-test. Across 2 trials with independent tobacco hornworm development cycles, the data indicates that cold temperature exposure generally had a negative impact on hornworm growth and development. In both trials, the group without cold exposure consistently grew the largest. In the first group, the group exposed to cold for 5 minutes outperformed the 10 and 2-minute groups, which suggests a benefit to moderate cold exposure. But that's something that we'd have to further test to find out. And then differences in results between the 2 groups could be due to genetic variation, handling variations, room temperature fluctuations, or possible fungal or bacterial contamination. And our next step in the experiment would be to run the experiment using warm-blooded animals such as mice to see the results.